Okay, this is Aquaculture 2. This is the second video in the aquaculture lecture. And we capped off last time with talking about some of the species that you might find being cultured around the world. And so if we look at the aquaculture types, a couple of definitions that you'll need to know for your exam. Extensive. This is a type of aquaculture where you only intervene in the life cycle of that organism for a short period of their life, or maybe a long period of life, but some part of their life cycle actually is lived out in the wild. Scallops are one where you capture the larvae that are just settling and then hold them in an aquaculture setting for a few months. Trout would be another one where you have a few breeders, or you capture breeders from the wild, and then you take their eggs, and when they're fertilized, you grow the hatchlings until they are past the point of their life cycle where they're most likely to die. You get them through the highest mortality period of that life cycle and then release them. So it's the same with the scallops or the trout. What you're doing is trying to increase the production of a fishery. Okay, so that's extensive. And intensive is where you provide for the well-being of the organism throughout its entire life cycle. So for a pawa, as you'll get to see if you take Aquaculture 2 next year, if you go up to Niwa, then what you can do is, what they do up there is they have their brood stock. They hold their big breeders in tanks, and they've taken breeders from all over the coast of New Zealand, so they can hopefully get the characteristics of different populations, and they hold those. They get them to breed. They stimulate them to spawn, and they take the offspring, raise them through the larval stage to the settlement stage, and then grow them through their entire life cycle all the way to harvest. And that is an intensive system. Okay, another definition: polyculture. This is being a little bit smarter, where you're trying to mimic some of the natural ecosystem and avoiding large stands of single crops or monoculture. And you put multiple organisms in the same system. Okay, so for example, tilapia and watercress, or carp and rice paddies, these are both freshwater systems where crops are being grown in aquatic habitat. And if you add fish to those habitats, such as tilapia or carp, then you get a couple of benefits. If you think about what a plant crop needs to grow, generally, it's some sort of fertilizer and light. Okay, the light we can't do anything about, but with the fertilizer, by adding fish that are pooing and weeing in that system, then you're automatically fertilizing the water. Okay, so you get carp and tilapia, and the waste products of those animals help the plant crop to grow. Now, of course, you can harvest both the carp and the or tilapia and the plant crop, but there's a benefit also to the animals in there, and that is that when you get these monocultures of crops, you tend to have pests that will specialize on eating those crops, and so you can actually reduce your insecticide use by adding some of these fish. They will tend to eat the larval stages, or the actual adult stages of the pests that eat the rice or the watercress or other crops, and so you can actually reduce your need for pesticides. So there can be a benefit, a synergistic benefit by polyculturing organisms. Sea cucumbers tend to go along and eat the organic material and a lot of the bacteria that live in the organic material along the bottom of the ocean, where you have mussels. They do tend to have a lot of waste, which settles on the bottom. And if you this is all sort of in the experimental stage right now, you may be able to culture sea cucumbers underneath the mussel farms. And you wouldn't think so, but sea cucumbers can be incredibly valuable. And in a lot of places, around the world, the wild populations have been overfished, devastatingly so. Okay, so what are some of the benefits of aquaculture? And especially in terms of fisheries management. Because that's what you're in here for. You're in fisheries management class to know about fisheries and the implications of different systems and different things on fisheries. And aquaculture, of course, has those relationships. And so let's have a look at some of the benefits. Okay, protein production, food shortages, and overfishing. In terms of overfishing, we may be able to increase fisheries production by releasing juveniles. And also, as we've talked about before, there is going to be a shortfall if population of humans keeps increasing in terms of the demand for seafood versus the supply that we can possibly take out of the ocean. All right, employment opportunities. So some of you are probably thinking about aquaculture as a possible career. So there may be jobs for you in aquaculture. And if we equate this to millions of tons of food around the world being produced by aquaculture, then that's a lot of employment. Supplementation of wild stock. Okay, so recreational and commercial. This is what we were talking about before with trout, scallops. Ornamental species. Okay, the aquarium industry, many places around the world, and easy to access reefs. All of the little Nemos and hi-hats and lots of other different tropical species get slurped up very quickly, caught with using cyanide and other sprays, anesthetics, I suppose, that they put into the water to be able to capture these things, which are very unhealthy for the corals as well. But it's big industry, people diving for ornamental species. The education can be furthered through aquaculture, sort of somewhat like Kelly Tarleton's, as you'll see in Conservation Issues and Perspectives. Human health. Everybody's talking, or lots of people are talking about the benefits of things like omega-3s and also eating and drinking seaweed in your diet. So this is most people are iodine deficient. You can get a lot of iodine from ingesting seaweed. Okay, so human health could be improved. And pharmaceuticals, drugs, artificial, natural sunblocks, anti-fouling. So there are maybe ways to grow organisms that can provide drugs, such as the cancer-fighting sponge that we talked about in inverts. All right, so now that you decided you're going to try to get a job in aquaculture or start your own aquaculture farm and help with all these benefits, help with the economy and also make yourself a few bucks, what are you going to culture? So here's a tough question. How do you pick what animal you're going to culture? Okay. Here are a few of the things that need to be taken into account. So the condition and stamina, the hardiness of the organism. Okay. all good and well to say that you're going to go ahead and culture orange roughy. All right, but can you culture orange roughy in a non-pressurized tank that doesn't simulate the conditions of that are found at 800 meters below the surface? And can they take a range of temperatures? If your chilling system breaks, are all of your stock gonna just die? Okay. Disease, local or introduced species. Okay, so if you just like in this classroom, or if any of you have kids, when they go off to kindergarten or into school, one kid gets a cold, and next thing you know, everybody's got it. Because what's happened is those kids are absolutely packed into that classroom. It's the same with aquaculture. If you're packing organisms way beyond the density that you'd find in the wild into a cultural system, the disease can go quickly through that population. Okay, the number required. All right, so how many are you going to need in order to make it profitable? The growth rate. Okay, so lots of people have looked at culturing crayfish, and the problem is, as we learned in inverts, is that if you're going to culture crayfish, you've got to, and you're going to take them right from spawners. When the larval stage takes months and months, and they settle, and then they grow for about 5 to 6 years at a minimum to get to a legal size. So in order to culture that organism, you're going to have to go for 7 years without any profit before you even start to be able to sell some of your stock. So that's a fairly slow growth rate, and is probably going to be uneconomic. Okay, life history stages. As we said before with the crayfish, as we learned in inverts, their larval stage can last 6 months. They've got to float around in the water for 6 months or even longer, eating plankton and before they even settle. So you would have to maintain a system where they could live in the plankton and keep adding things that they could eat, which would be little bits of phytoplankton or smaller zooplankton than the larval crayfish, because they need something smaller. So you'd actually have to add the stage to it, which would be very, very difficult to do, and to do well, and to keep them clean and all for 6 months, even just to get them to the settlement stage where they might be able to eat solid food. Okay, so it's very complex. It's taken a long time for people to be able to work out the PAWA life history, or larval settlement of PAWA. Okay, but now they've finally cracked it. It's still very expensive to produce those organisms, but it is, and it's only possible because there's such a high return on the PAWA per kilo. Water quality. Okay, this is like oysters have had a bit of a problem in farms in Northland, because of the towns up there. The local councils have not been very supportive. There's only so much money to upgrade their sewage system, and their sewage system has not kept up with the growth of humans in the area, the growth of population in the area, and so now the problem is that when there's a huge amount of rain, then they have dispensation to just dump sewage into the local rivers, and of course, when that happens, the water quality goes down, the E. coli fecal coliform counts go way up, and then you can't sell your oysters. So because the water quality has not been very good in some of the Northland farms, and they haven't been able to sell their oysters for months and months on end, some of them have gone bust. Okay, so water quality has to be of a standard that you can raise healthy organisms that aren't going to make you sick when you eat them. Okay, legislation and permits. Okay, this can be quite expensive and can be quite time-consuming. Acceptability. Okay, so all good and well to say raise dolphins, but if nobody wants to eat dolphin meat in New Zealand, then the market is not going to buy that, and you're not going to be able to make a profit. Okay, and then the cost set up and run aquaculture systems are notoriously expensive. The Pawa farm up at Bream Bay, they are lucky enough to have the infrastructure to get the water to feed their system put in when the Marsden power plant was put in. Now, this was a coal-fired power plant that, in fact, was built but never really turned on. So and what they have is a cooling system that takes seawater in and then pipes it back out. It goes out half a kilometer offshore or something like that, and is filtered, and so it's a way of sucking water in. Now, in order to put that infrastructure in, it would have cost probably $10 to $15 million, but that infrastructure was already built, and they just happened to be able to tie into that infrastructure in order to supply their farm. Now, that farm has already sucked up $14 million worth of startup costs, and that's with no returns for at least 4 years, because that's how long it takes to get the Pawa to a sellable state. So, in terms of the cost for that Pawa farm, to set up your own, a similar one, without the permits, you're probably talking $20 to $25 million. Okay. Is there much aquaculture production in New Zealand? Okay, in New Zealand, it started small scale in the 60s, and has grown mostly through the mussel farming. The total area utilized in 2008 was 14,188 hectares, and each hectare generates $42,000 on average on export production. That was 2008 figures, so it's probably going up a fair amount since then, in 5 years. Okay. 7,713 hectares is owned by the aquaculture industry. Known productive growing areas. Some will be scallops, some will be, it's not scallops. Some will be salmon and some will be mussels. 4,010 hectares belongs to the Challenger Scallop Enhancement Company, is used to enhance the wild scallop fishery. So there's a website you can go and have a look at, a document that describes that scallop enhancement. And so those are areas where scallops are caught and then taken to shore, raised through their most vulnerable stages, and then reseeded into that area, and then commercially harvested. Okay, and the rest is on exposed site offshore from Napier and Podkey. And these are for offshore mussel farms, and they're still trialing whether this will happen. Okay, so here you go. Here's a picture of the East Cape to the Bay of Plenty. So this is just to the east of us. Bukina, all right, Whakatani's here, Podkey, and the Ohiwa Harbor. All right, and so these red areas are considered very suitable for growing mussels in with deep water lines. And So there's quite a bit of area that has been granted to be used for offshore lines. Right now, they're just they've put in lines that sit in quite deep water. Maybe they'll be 15 meters below the surface, so they're less susceptible to large waves, and they're seeded with mussels. Lots of phytoplankton coming off here, or coming along. Well, the currents come this way, but a lot of phytoplankton in the water here. Tends to be fairly green water, and that you keep them at a deep enough level so that boats can still pass over the top and grow the mussels in this area. And they've put in some trial lines which have grown very well. The only problem is getting them to the market, and so this is the Podkey Bar, and if you wanted to be able to set up a system where the barges could go out, tend those lines, and work in this environment quite easily, then they need to be able to get in and out of port in pretty much any weather conditions, or just about any weather conditions. Right now, they can't. They won't be able to cross this bar in any weather conditions. But there's a proposal to put a big jetty, or not really a jetty, but a seawall that comes straight out in this area and make this channel come straight out. All right, so it's still going through resource consent, but also and it has iwi support behind it, so they could probably get the resource consent, but the money to put into this in order to get to do this build is huge, in the millions of dollars, and also the startup costs in building the system offshore are quite big. So, but that is potentially that could produce quite a bit of seafood, quite a bit of mussels offshore. All right, in terms of what species we do farm and the dollars that comes in, the most valuable product is green shell mussels, 90% by weight, 62% by value. Salmon, 7.2% by weight, 28% by value. So obviously, the salmon are a lot less of it is cultured, but because they are worth a lot more money, then they add a lot more to the value. Oysters, 2.6 by weight and 9% by value. Okay, and then a little bit of paua, rock lobster, freshwater prawns. Okay, so those are just minor players. The rock lobster isn't really grown intensively so much as held in tanks. From the commercial guys will bring it in, hold it in tanks, and then be able to ship it out when the price is the best. Okay. And we will continue on with farming, with oyster farming on the next video.